All right, so let's look at how we can express some ratios for right triangle trig using sine, cosine, and tangent. So some things to note is that you can refer to an angle by either its name or a symbol. So I'm going to write that down. Refer to angles as letters or symbols. All right. Common symbols are using Greek letters. For example, this right here is the name theta. Right? That's a very common symbol to use when you're referring to an angle. We also use this, looks like an uppercase B with a little tail on it, and that one is called beta. And sometimes we use what looks kind of like a little fish, and this is called alpha. Right. So those are three really common symbols to use when you're referring to trig instead of using vertices. So I'm going to draw a triangle and I'm going to label its sides. And so, for example, let's call this letter A, letter B, and letter C. Go back to the old school ones. And I'm going to label this side 3, 4, and 5. So when we have all of the sides labeled, I just want to be able to say what are the ratios of the sides depending on the angle we're talking about. So for example, if I want to find the sine of A, that is going to be referring to this angle. And again, sine, using SOHCAHTOA, is opposite over hypotenuse. So the opposite side over the hypotenuse, the ratio is 3/5. And we would just leave it like that because we're just expressing this trig function with this angle and the ratio of this specific triangle. Also, if I want to talk about the cosine of angle A, again, cosine of angle A is the adjacent side over the hypotenuse, which is 4/5. And then the tangent of angle A is the opposite side over the adjacent side. So you do really want to remember SOHCAHTOA so that way you can figure out the different ratios. Now sometimes you're going to be missing different pieces, and that's okay. You're going to need to sometimes use the Pythagorean theorem to figure out what it is that you're going to have to do. So for example, if I look at a triangle and I say, let's call this side 12 and this side 13. All right, and I'm going to call this right here, I'm going to give it one of these names so you can see how this works, and I'm going to call this one right here theta. So I still want to be able to find sine, cosine, and tangent of that angle. So the first thing though is I'm missing this side. So I do need to use the Pythagorean theorem in order to find this missing leg right here. And that's going to be the first thing. So I'm going to say a squared plus 12 squared is going to be equal to 13 squared. Right, and so I'm going to shortcut this a little bit. So 13 squared is 169 minus 144. And so a squared is 25, which means that the side A is just 5. So I'm going to simplify that down a little bit. Don't show as much work as last time. And now I can answer the questions. What is the sine of theta, the cosine of angle theta, and the tangent of angle theta? All right, so now that I have all three sides, I can actually answer that question based off of this theta. What are the trig ratios? And so again, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is always opposite over adjacent. Okay, so it's going to be really important that you remember those different trig functions. Now another thing that we can do with SOHCAHTOA is not just being able to find their ratios, but we can find missing pieces of the triangles. For example, I can find a missing side of a triangle by using SOHCAHTOA, or I can find a missing angle. Right? So let's look at some other trig that we have done in the past using SOHCAHTOA. right?